Welcome back, Algebra. This is Mrs. Ayers. So, sorry for the delay in this. I've been setting up a way to work from home. Believe it or not, I did not have a computer pretty much since college. So, I had to get one yesterday from some funds from the school, from your parents. So, thank you all so much for donating. We were able to get some equipment in order to provide some better instruction for you, and also so I can continue to provide you guys with these instructional videos. So let me know if you guys like this technique better, or if you like me in front of the whiteboard. I'd be interested to know your guys' opinions. So let's get started. Number one, we're going to be multiplying the square root of 8 times the square root of 20. And in order to multiply these two numbers, we can multiply the radicands, 8 times 20. And there's two ways to do this. You can multiply 8 times 20 and then look for your perfect squares. But I think it's easier to break down into perfect square factors that you already know. I know that 4 is a perfect square, so I can break this down, 8 into 4 times 2. And then I could break the 20 into 4 times 5. And the reason that this is really nice is because notice here that I now have 4 times 4, which is 4 squared. And if I take the square root of that, then I know that 4 squared, the square root, is going to be 4. So I can move that 4, if I have 2 of them, to the outside of the radicand. And what I have left is 2 times 5, which is going to be 4 square roots of 10. In the second problem, I have the square root of 45 times the square root of 3. We can use the same method. Let's break 45 down into a factor that's a perfect square and another factor, and multiplied by 3. I know that the square root of 9 is 3, so I can bring that out in front of my radical sign. And left within the radical is going to be 5 times 3, which is 15. So the answer is 3 square roots of 15. Okay, let's look at number 3. I just realized that I mixed up the answer. So let me put in the original problem was the square root of 12 over 27. And so in order to evaluate this, we can break it up into the square root of 12 in the numerator, divided by the square root of 27 in the denominator, simplify each of the radicals. So for 12, I can break this up into the square root of 4 times 3 in the numerator, and in the denominator, 27 has a perfect square factor of 9 times 3. Then I can take out these perfect square factors, the square root of 4, the square root of 9, okay, and be left with 2 square roots of 3 divided by 3 square roots of 3. Okay. And this is really nice because I have the square root of 3 divided by the square root of 3, and any number divided by itself is going to be 1. So the only thing I have left is 2/3. So the answer here would be 2/3. In the last example, we are going to be rationalizing. Remember, you cannot have square roots in the denominator. So in order to eliminate those square roots, we multiply both the numerator and the denominator by that denominator piece. So we're going to multiply the numerator and the denominator by 2x to the third power. If I have 2x to the third power times 2x to the third power, so meaning that I'm going to square it, then I'm going to be left with simply 2x to the third power. However, in the numerator now I have 5 times the square root of, and notice here that, well, 5 has no perfect squares, but x to the third does. I can break this up into x squared times x. And so the square root of x squared is 1x, which I can bring out to live outside here with this 5. So now I have 5 times x times the square root of x, all divided by 2x to the third. And I can simplify that one more time. If I have an x in the numerator and x in the denominator, remember your exponent laws where you can subtract your exponents. So here, notice that my exponents, if I have, come look at the top of the page, x over x to the third is going to be x to the first minus x to the 1 minus third power. And so 1 minus 3 here is going to be -2. And in order for this to be positive, he needs to live in the denominator. So that's why if you have 1 up here, you can take it away by, you can take an x away from each of these, and that's the explanation of y. So if I take an x there, and I can take one away from here, and it becomes x squared. So your final answer would be 5 square roots of x divided by 2x squared. In this next set of problems, we're going to be finding the missing length using the Pythagorean theorem. So let's recall what that Pythagorean theorem is. It is going to be a squared plus b squared is equal to c squared. So in the first problem, you want to identify your right angle. That's going to tell you what your sides are. So my first leg is going to be 13 squared plus the second leg, which is x squared, and set that equal to your hypotenuse here, which is the side that is opposite of the right angle. And so that's going to be 15 squared. Excuse my messy handwriting. I am getting used to writing with this. I have a writing tablet, and it takes a little bit of practice. So 13 squared is going to be 169 plus x squared is equal to 15 squared is 225. Now I can subtract 169 from both sides. Okay, wind up with x squared is equal to, so x squared is equal to 56. Now in order to complete this problem, we need to take the square root of both sides. And the square root of x squared is just x, is equal to, take the square root of 56, and you'll be left with 7 and approximately 7.5. I believe it says to round to the nearest tenth. Okay. In the next one here, look for that right angle. That's going to tell you what the legs are. The legs here are going to be 19 squared plus x squared equal to my hypotenuse of 24.3 squared. 19 squared is going to be 361 plus x squared is equal to 24.3 squared, which is 590 4900ths. Okay. Then you can subtract 361 from both sides. So that x squared is equal to 229 and 4900ths. To finish this problem, you would take the square root of both sides. So that x is equal to 15.1, approximately 15.1. Okay, and oh, I forgot here also to put my units, centimeters, inches, and let's move on to do the last problem. Okay, again, look for this right angle, find your legs. I'm going to do this last problem in green here. So my legs are going to be 7 squared plus 5 squared is equal to x squared. 7 squared we know is 49 plus 25 is equal to x squared. 49 plus 25 is going to give you 74 is equal to x squared. Take the square root of both sides. The square root of x squared is x. And so x is equal to 8.6, approximately 8.6 feet. In this next set of problems, let's determine whether the given lengths can be sides of a right triangle. So again, this is going to be another Pythagorean theorem problem. A squared plus b squared is equal to c squared. Looking at the first one, remember that the longest side here is always going to be the hypotenuse. So that means that your other two here are your legs. So this is the legs and the hypotenuse. So my legs are 9 squared plus 12 squared is equal to 15 squared. Okay. 9 squared is 81 plus 144 is equal to 225. Okay. 81 plus 144, you can add these together. Does 225 equal 225? And yes, it does. So yes, this is a right triangle. Next one, I have 2 squared plus 4 squared. Is that going to be equal to 5 squared? 2 squared is 4 plus 16 is equal to 25. Does 20 equal 25? No, it does not. So this is not a right triangle. Not a right triangle. All right, last point, we're going to find the midpoint of the segment shown at the right. Then find the length of the segment to the nearest tenth. So first going to start with, for part A, with our midpoint formula. And the midpoint formula says that we need to add our x values, divide by 2, and then take the average of the y values by adding them and dividing by 2 as well. So in this problem here, look for your x values, -4 and 4. So I have -4 plus 4 divided by 2. And my y values here, -2 and 3. So I have -2 plus 3 also divided by 2. Now I can do the math on this here. -4 plus 4 is 0, so 0 divided by 2, which is going to just be 0. And then I have -2 plus 1, which is 1 over 2. So the midpoint here is at 0, 1/2. 0, 1/2. And for part B of this problem, it says to find the line segment. So that's going to be our distance formula, which is going to be x2 minus x1 squared plus y2 minus y1 squared. And so for this problem, I'm going to go ahead and come over here and I can label these guys. And so I'm going to label A to be x1, y1, and B to be x2, y2. Now, if you label them opposite, then you should notice here that if you've done it correctly, we're still going to get the same answer. Okay, so x2 here is 4 minus -4 squared plus y2, which is 3 minus -2 squared. 4 minus -4 is 0 squared plus 3 minus -2, which is 5 squared. The square root of 25 is just going to be 5. So this is 5 units in length. Hope you enjoyed this video, and hopefully I get better at this with the handwriting. Please let me know which one you like better. If you have questions, your quiz before your quiz will be on Monday. You'll be getting a link in your email to take the quiz, and you'll have until midnight to complete it. And again, if you have any questions, email, call, or text. Bye.